All right, students of marine science, welcome back. We are starting Unit 3 today, Properties of Water and Ocean Chemistry. And our first lesson for the day is going to be on the basic chemistry of water itself. You don't have to do it, but if you get a chance, watch the crash course video related to water. I don't think the link works in the slides, but if you just go to YouTube and put in crash course water, and find that episode. Again, not a requirement, but if the stuff I say today doesn't make much sense, then maybe you'll understand the way they explain it a little better. Keep in mind, as we work our way through this, you should be completing your 3.1 page of the new Unit 1 or Unit 3 study guide. Page 1 of the Unit 3 study guide. So the first question says, describe the difference between an atom and a molecule, and then what is a compound, and give an example. So this will be over a couple of slides here. We're going to answer this question. Matter consists of elements, each of which naturally occurs as a small unit that we refer to as atoms, and atoms can be found alone. Helium is an example of one that can be found alone, or they can bond to other atoms and become a molecule. So some example of elements are hydrogen and oxygen, as well as helium, which was already mentioned on the slide. Anything that we're going to find on the periodic table, these are our atoms, these are our elements. So a molecule is when two or more of those atoms bond together. Now they can bond to each other. Oxygen is an example of that. You can have O2, just two oxygens. Water is a molecule, but it is also a compound because it has more than one element. So a tip for spotting a molecular compound is that they typically are going to have a longer kind of multi-word name since they're a combination of different elements. So sodium chloride is an example of that. That's the salt that we find some other salts in ocean water as well, but that's the primary salt that we find in ocean water. It also happens to be table salt. And so that it's sodium is an element, the chloride is an element, and it comes together to form a compound molecule, NaCl. So molecular structure, in the water molecule H2O, there are going to be two atoms of hydrogen and one atom of oxygen that are chemically bonded together. There is going to be a question on the test asking you how many total atoms are there in a water molecule, and you'll need to be able to identify that there are three. You got your two hydrogens and one oxygen. So let's see. Yeah, we just mentioned covalent bonds here. This is where atoms share electrons. There aren't going to be any questions on the test related to that, and so I'm going to skip going into much detail there. What makes water a polar molecule? You may want to go back though for number 2. It says sketch a water molecule. I think that's why I had this slide here. It's got the nice sketch here for us of what the water molecule looks like. And then we move on to number 3, why is water considered a polar molecule? So for polarity, the oxygen in a water molecule has a negative charge. He's the big greedy guy. Takes up more electrons. And then the hydrogen, so there are two of them. The two hydrogens have a positive charge, and they have more protons than they have electrons. And so each end of the water molecule has a different charge. You've got a negative end up here and a positive end down here. And when you have negative on one end and positive on the other, that's going to equal polarity. So polarity is the state of having two opposite or contradictory tendencies. So in chemistry, polarity is the separation of an electric charge, a leading molecule to have an electric negatively charged end and a positively charged end, and water fits that criteria. So it is a polar molecule. So each water has a slight positive, slight negative, and the positive charges are near the hydrogen end of it, the negative charges are near the oxygen end of it. You don't have to memorize or have any of that written down, just reiterating. So water's polarity allows it to bond with many substances. This is what gives water such great dissolving ability. Notice that's in bold. There is a question on the test asking why water has such great dissolving ability, and its polarity is going to be the answer to that. We'll talk later kind of how solutions form, how things dissolve into water, but for now you just need to know that negative and positive charge at either end allows it to grab hold of other things that eventually end up being part of the solution as water mixes with other stuff. So due to these slight electrical charges, water molecules are attracted to one another, and the negative charges of one molecule attracted to the positive charge of the other molecule. This attraction of a water molecule to another is known as hydrogen bonding. I just want to throw that term out there for you, hydrogen bonding, but don't worry about it too much. I want you to focus here on this, cohesion. So this is the sticking together of particles of the same substance. So there are some different things out there that have cohesive properties, but because water contains a large number of hydrogen bonds, it has more cohesion than any other liquid. This is one of the special properties of water. This idea of cohesion, its ability to stick to itself. So water's tendency to stick to itself is because of those hydrogen bonds. We do have that in bold now, so you can go ahead and put that down as part of your explanation for cohesion. But when you take a look at these images here, we've got the penny with the bubble of water on top. If you do that with another liquid, for example, vinegar, which you'll get to see a lab demonstration in a few days that will show how that works. But with other liquids, it will not do that. It won't pile up on top of the penny like that. It just falls off and spills. But water has the ability, it's a limited ability, but has the ability to hold on to itself like that. You keep on putting more water on there and it will eventually burst, and that one's pretty close to bursting. And then here we see this guy looks like he's floating on top of the water, but he's not floating. He's standing on top of the water's surface tension, because of that water's ability to hold on to itself. I'm going to talk about surface tension more in just a second. So surface tension is at the top of a body of water. So it is the kind of the measure of the elastic tendency of a liquid, and water's surface tension is greater than other liquids. It forms I do want you to catch that little line at the bottom there. That forms a membrane at the water surface. That's the part that I want you to have written down. I'm not going to walk you through all this. I'm going to show you this image. I think this is pretty spectacular. They caught this at exactly the right moment. The water would not stay that way for very long. There's quite a bit of pressure there on that water that will burst that surface tension. But just an incredible image there, being able to see that membrane of water as it tries to hold on to itself. This person is apparently a very smooth swimmer to be able to capture an image like that. So now we move on to adhesion. This is still part of number 4. So adhesion is water's tendency to stick to other materials. Or cohesion is when it sticks to itself. Adhesion is when it sticks to other materials. So an example would be leaves. You'll see this sometimes with gutters as well. It adheres to some substances better than others. It doesn't just stick to anything and everything, but you can see it, here sticking to the leaf, clinging to it, holding on to it. So just an image here of adhesion versus cohesion. In the middle here, where the water molecules are sticking to themselves, that's going to be the cohesion. And here on the outside, it's sticking to these outside surfaces. That's the water adhering to other substances. Wringing out a towel in space. There's a video. It's not going to work in the link for the slides, but I'm going to post the video separately. I think it's about 3 minutes. Really cool video of an experiment that is done in space that really shows this idea of how water sticks to itself. So please watch that. Hydrogen bonding. I'm not going to worry about that. So 3 states of water. For number 5, just ask us, is water more or less dense as a solid, and why is that important? So we're going to kind of work our way towards that answer. Water is the only substance that naturally occurs in all 3 states on Earth, solid, liquid, and gas. Only substance that naturally occurs in all 3 on Earth. So in liquid water, the hydrogen bonds hold the molecules together in small groups, and if heat is added to the water, then the molecules break free of the hydrogen bonds and they go into their vapor state. They let go of each other and become a vapor. We refer to that as evaporation. So the molecules of a water vapor are held together by those hydrogen bonds, and the water boils, it becomes a gas. When nearly all the hydrogen bonds are broken, then many molecules enter the vapor phase at once. They're all at once. They're all becoming vapors. When water freezes, it becomes a solid, and when the molecules move so slowly that the hydrogen bonds form among the molecules. There's an image here of the different states of water. As a gas, the molecules are separate. Here they're kind of bonded in small groups, and then here they are all bonded together. So here's the part that we want you to catch. So this, for the sake of marine science, this is an incredibly important detail here. Water is extremely unusual in that it is less dense as a solid than it is as a liquid. It is less dense as a solid than it is as a liquid, which is why ice floats. Any other substance, when it becomes a solid, that solid is going to be more dense and is going to sink to the bottom. But for water, when it becomes ice, it floats to the top. And this is incredibly important because that floating layer of ice insulates the water below so that it doesn't freeze. Otherwise, much of our ocean would be frozen if not for this insulation that occurs with ice freezing at the top and keeping the rest of it underneath from freezing. So the ecosystem there isn't destroyed. It has ice over the top of it, but there are still things that live under that ice, which obviously would not be the case if the whole thing were ice, if it froze from the bottom up. So organisms can live in the liquid water below that layer of ice. So incredibly important when it comes to our marine science ecosystems. All right, we're gonna leave it at that. I know that's kind of a tricky lesson. That seems to be one of the harder ones that we'll do all year long. When we get to the chemistry side of things, we don't do a whole lot of chemistry much of the rest of the year, just a little bit in this unit. So if there's anything there that you really didn't understand, there are probably some stuff in there that you didn't get, that we didn't cover too in depth. But hopefully if we didn't cover it in depth, that's because it wasn't something you're going to need for the test. So just make sure you got the stuff that was in bold, that you have your study guide properly answered, and if you have everything on here that the study guide is asking for, then you should be in good shape. Don't worry if there were some other things in here that were over your head. They might have been over my head too. Have a good one.